Gravity, the invisible force that holds everything together. But how exactly does it work? Today, we're going to unravel one of the universe's most fundamental mysteries. Welcome back to Explorer-Sphere. Ever wondered why you don't just float away into space, or why your coffee stays in your mug instead of flying off the table? It's all thanks to gravity. But gravity isn't just something that keeps you grounded. It's the force that governs the entire universe, shaping everything from the tiniest atoms to the massive galaxies. So, how does it work? Let's start simple. Gravity is a force of attraction between two objects with mass. That's it. Whether it's you and the Earth, or Earth and the Moon, or even the Earth and the Sun. The more mass an object has, the stronger its gravitational pull. Everything with mass creates gravity, and it pulls other objects toward it. The Earth's gravity pulls us toward the ground, keeping us from floating off into space, while the Sun's gravity pulls on the planets, keeping them in orbit. Now, you might be thinking, okay, I get it. Gravity pulls things. But how did we figure all this out? Well, back in the 1600s, an apple falling on Isaac Newton's head sparked a brilliant idea that changed science forever. He realized that the force that pulled the apple toward the Earth was the same force that kept the Moon in orbit around our planet. Newton came up with the law of universal gravitation, which states that any two objects with mass attract each other, and the force of that attraction depends on two things: the masses of the objects and the distance between them. Here's the formula. That's a lot of math, but don't worry, we'll keep it simple. F is the gravitational force between two objects, m1 and m2 are the masses of the objects, and r is the distance between them. The bigger the masses, the stronger the pull. The closer they are to each other, the stronger the force. But gravity isn't the same everywhere. The strength of gravity depends on the mass of the planet or object and how far you are from its center. That's why you weigh less on the Moon than on Earth, because the Moon has much less mass and its gravity is weaker. On the Moon, gravity is only about 1/6 that of Earth's, so you could jump higher and float around more easily. But on Jupiter, the biggest planet in our solar system, gravity is about 2.5 times stronger than Earth's, making it nearly impossible to escape its pull. Now, Newton's laws were groundbreaking, but they weren't the full story. In the 20th century, Albert Einstein came along and revolutionized our understanding of gravity with his theory of general relativity. Einstein said that gravity isn't just a force between objects. It's actually the result of massive objects bending space and time itself. Imagine space like a stretchy fabric. When a planet or star sits on it, it warps and curves like a heavy ball resting on a trampoline. Smaller objects, like satellites or even light, move along the curved paths, which we perceive as gravity. Instead of thinking of gravity as a mysterious force, Einstein showed us that it's more like a cosmic dent in the fabric of space and time. And that's why planets don't just fall into the sun. They're constantly moving along the curved space-time path created by the sun's mass. Gravity isn't just important on Earth, it shapes the entire universe. It's responsible for forming stars, galaxies, and even black holes. When massive stars collapse under their own gravity, they can create black holes, where gravity is so strong that not even light can escape. And thanks to Einstein, we also know that gravity can cause ripples in space-time, called gravitational waves. These waves were first detected in 2015, proving that gravity isn't just a force, it's a phenomenon that travels across space itself. Here are a few fun gravity facts to blow your mind. If you could survive the journey it would take just 11 minutes to fall to the center of Earth. The Earth's gravity is constantly pulling on the oceans, which causes tides. If you were on Jupiter, your weight would be 2.5 times what it is on Earth. And finally, did you know gravity is not the same everywhere? In fact, there are places on Earth where gravity is weaker, like at the equator. Gravity is one of the most fundamental forces in the universe, and even though we can't see it, it shapes everything we experience. From keeping us anchored to Earth to guiding the orbits of planets, it's the invisible force that holds the universe together. And who knows, maybe one day we'll discover even more surprising things about gravity. The adventure of science never ends. Thanks for watching. If you learned something new, give us a like and share the video with your friends. Don't forget to subscribe for more mind-blowing science. What topic should we explore next? Drop your ideas in the comments below.